Good afternoon, I'm Mark Weisheimer. I'm here today with the Volt Auxiliary Power Module, or DC to DC. This is a unit that came from a 2012 Chevrolet Volt, and you'll see some other things on the cart here. A couple of the Lear chargers. I've got a 55 amp hour AGM battery. I've got a Xantrex sine wave inverter. That is hooked up to the 12 volt output of the DC to DC converter, and it's there as a load because I can't find any way to load 12 volts down to 175 amps otherwise. So a 2 kilowatt inverter with the DC to DC converter from a Chevrolet Volt, 2012 model in this case. We've got a high voltage input coming from one of the better placed battery packs. We're outputting 385 volts from this battery pack. It is, let's take a look here. We have 383.4 volts output. Presently we're doing 3.9 amps. We're drawing, I don't know if you can see it on the kilowatt meter that's on the face of that. I've got a couple of electric heaters hooked up because it's the only loads I have big enough to load this thing down. We are drawing currently 1200 watts and this is just barely warm. This is an air-cooled DC to DC converter. I've got very large output cables. These are 1/0 copper output cables feeding into the Xantrex inverter, and so I've got it set up. I've got a CAN line here that I'm driving. I'm using a microchip CAN analyzer. It's a very simple interface. It's 500 kilobits. It takes 12 volts control on 2 wires into the 10-pin plug. It's all very well documented. My cohort in this, one of is Branka Shane, and he's done a beautiful documentation on this. It's on the EVT forums under the Chevrolet Volt category, and it's real simple. You basically you're going to apply 12 volts to 2 of the control lines. You're going to put CAN data into it. It only uses a 1-word command message with 2 bytes. You're basically requesting your output voltage, and you're telling it to turn on or turn off. So the first byte that it uses sets a couple bits to output, and if you set them to 0, it stops outputting. If you then in the second byte are going to select the output voltage, it uses a multiplier. That's in the documentation. Take a look again on the EVTV website. And this is an air-cooled DC to DC converter, one of the largest that I've worked with, and one of the hardest to put a big load on, hence my whole giddy up here. The air cooling on this comes into a 6-inch wide by 3/4 inch tall air duct. It flows through the cooling fins and out the other side here. It's the same size outlet or inlet. I don't know which is which, but you could probably do it either way. You'd probably want to use a filtered air affair. This is located in the trunk of the Chevy Volt. We were fortunate enough to get a CAN capture using a CAN Dewey from a gentleman in Washington, Jim Hanna, and thanks, Jim. That was really helpful. It let us look at what Chevrolet was using in their command of the DC to DC converter, and it's very interesting. They use a pretty aggressive command scheme in there, or pretty aggressive voltage scheme in theirs. They use a larger AGM battery in that car, and AGMs typically run just a little higher voltage than you're going to see in a lead acid 12 volt system. This thing's got the power of 2 big internal combustion engine alternators, so it's a kick butt inverter. What I'm doing with it today, I've got a kilowatt meter here on the output. I've got it loaded to 1200 watts at the moment. I'm going to turn on a second one, and I'm drawing 118 amps. Now we're to 120. We're drawing 1400 watts. I can't get much more aggressive with that because my kilowatt meter starts squawking it much above that. We'll try it anyway. There's 1800 watts. 172 amps, 173 amps output. We're drawing 6.5 amps from the 383 volt high voltage battery pack. The squawking is the kilowatt. So a full 175 amps out, and it shut down because we did exceed its output amperage. I'll get it back. We shut down because the inverter went into fault. Alright, let's go ahead and tell it to stop. And we'll reset the parameters on this thing and go from there. Alright, there's that. Reset our inverter. Got an EO3 error on the Xantrex inverter. Turn it back on. It's happy again. Putting out 1300 watts. 175. I'll tell you what. Let's turn that second one off. Yeah, I know. We exceeded your output. You're not a happy camper. Okay. And back to the. We did not shut down the DC to DC. We shut down the inverter. So, like I said, it's hard to get a big enough load on this thing to really make the difference. It's a heck of a DC to DC converter. If you've got a load that you haven't been able to fulfill, this guy's going to do it for you. So, if you're interested, check out the EVTV forum. Get in touch with some of the rest of us. We've been kind of having fun playing with the different devices that are coming out of some of the cars. You can see the pair of Lear chargers there. They work great. They're liquid cooled. We've also got a Delphi DC to DC converter. It is liquid cooled as well. It puts out the same kind of current. It has an interesting function where it can do a back boost charge into the high voltage battery pack from the 14 volt system, just to bring it up enough to get your charger to turn on, because there are charging systems that won't attempt to charge until the high voltage battery pack is at a certain level. So it's something that can work with that. It's like 600 watt charging capability, but interesting. It's quite interesting actually. So if you're interested in playing with any of this stuff, the CanDooey is going to be an excellent tool to use with this. The volt capture that we got was done with the CanDooey. It was done by Jim Hanna in the state of Washington, who has a Volt, and it was extremely helpful to have that data can capture. If you've got a Volt or a Leaf or a Tesla and you're interested in some of the work that's going on to make these components available to use in your conversions, we would really appreciate getting the can captures, and you can do that. You can contact us through the forum, or you can contact Jack, and we can go from there. Good luck with yours. Thanks. Bye.